First of all, listen, there's a lot of ways to mess these up. And I'm serious, when I give people a formula chart and calculators, they tend to feel invincible. But first thing you have to do is choose the right formula. And then, so if it's compound interest, then you're for sure choosing one of the left two. In this case, which one? The first one. And when we're asked which formula, you can just put the formula number if you want. Formula number 1 in this case. How do you know? Because it said monthly. So in its finite number, 12 in this case. When is it going to be the second formula? Which problem? 1 through 4 is the second formula. 4 because it says continuously. Okay? And then once again, if you're not doing compound interest, that's when you use the other two formulas. Now, let's get this thing set up. You want to end up with $100 after 2 years, so the $100 is your final amount. Your principal is what you don't know. It was 2 years, we said. Remember, time is in years, so they could have said 24 months, but if they did, you'd write it as 2 years. You use 2, okay? And then the rate was 6%, which we'll use that way. Then you set it up. These are really just about the easiest kind. The easiest kind is where you just plug in everything on the right side and just spits out the answer on the left side. This is not quite that easy, but it's still not hard. So plug it all in, and then I would type all this in that's next to P, get a number. Here, let's do that. And just be careful with your parentheses, of course. There's monthly, so in this 12. And the next one is really just 24. So I got 1.127 something. Put it on my desk. Put it on my desk. So that means I can write my equation as 1.127p equals 100, which means I divide 100 by that to get p. And once again, do not do 100 divided by 1.12, don't do divided by 1.13 or 1.127 even. Use second answer. So $88.72. Once again, put appropriate units and round appropriately. If it's money, then I want to round to the nearest hundredth, obviously. If it's a rate, I want those expressed as percents. Usually round to the nearest tenth of a percent. And like I said, it would be easier if they gave this initial amount, because then you just plug it all in and spit out the answer. This is almost as easy. Let me jump to number 5. Now it gets a little harder. Which formula are we using in this one, number 5? Which one do we use? Which formula? Yeah, first one again, because it says quarterly, so n is a finite number, so we use that formula. You initially put 1,300, so that's your principal. You end up with 2,000. And let me say again, the bigger amount's not always the final amount, but it is here, because this is increasing. You want to find the rate. And it was, where was it? How many? Oh, 9 years. There is. I lost. All right, let's set it up. So 2,000 for the final amount, 1,300 for the initial amount, 1 plus r, which we don't know, over n, which is 4, to the power of 4 times 9, n times t. And we're going to have to solve for r, obviously. I'm going to divide by 1,300 first. I'm just going to cancel the showing zeros. To the power of 36. Now, I need to get rid of that exponent. How do you get rid of exponents? Are you using radicals or logs? You want to get rid of exponent, use radicals. In other words, we'll take the 36th root of both sides. Or you can raise to the power of 1 over 36. So an exponent of 36 will get canceled that way too. And the right side just becomes 1 plus r over 4. And the left side I'm not going to do anything with yet. I'm just going to bring that down. And we generally don't test the calculator until we do all the algebra. Now, to get r by itself, I'll have to subtract 1 and multiply by 4. Okay. Let me see a mistake. Yeah, the index should have been 36. And then like I was about to say, so you get 36.3 to that, minus 1 times 4. Where did I mess up, though? You need to have parentheses. Either put parentheses around the whole thing, which is what I'm going to do, or you could have just made it minus 4. 4 times both, in other words. And now type it in. And like I said, the ways to mess this up is first, use the wrong formula. Second, use the formula wrong. Plug things into the formula wrong. Third, do the algebra wrong. And fourth, type in the calculator wrong. So there's a lot of chances to mess up. Now, once again, to do a 36th root, you type in 36 first. Then hit math, 5, because that's the xth root. And then type in your radicand. And then make sure you get out from under the radical just before you do the minus 1. And there you go. And once again, I want that expressed as a percentage. And there's tenth, so that's 4.8%. Questions about that one? And just let me say this again, one more thing about this calculator. If you're just sitting there watching us type all these in, then tomorrow you realize you missed a step, do not ask me, because I'll say, that's your job today to learn how to use a calculator. All right, so number 6 then. Which formula this time? Yeah, it's a compounded formula, so it's one of the first two, but it's continuously, so yes, it's the second formula. Let me write that down. It's apert. And so initial amount of 750, final amount of 1200, 5 years, so it's 5 years. And there is no n. If you want to put infinity, you can, but otherwise there is no n in the formula. You don't need it. And we're solving for r again. So, similar setup. Both the initial and the final amounts. The rate we don't know. The time is 5 years, like we said. I'll go ahead and divide by 750 and drop the trailing 0. And I have an exponential equation with the base of d, so I'm just going to rewrite it as a log base e, which is really natural log, of that answer equals the exponent. And then obviously you divide by 5 or take a fifth of to get r by itself. Once again, it's really natural log. If you want to write it as log base e to help see the relationship between the exponential and the log, that's fine. But your final answer, you should never have log base e. It should always just be expressed as natural log. Now type that one in. And frankly, I'm going to show you 3 different ways to type that in. I expressed it as a fifth of, but you could have divided by 5. But I'll type it in the way I wrote it first. And then, like I said, if you divide by 5, that can work. You just have to make sure you close parentheses on the log before you divide by 5. So anyway you type it in, you should get 9.4%. Like I said, rates I want as a percent rounded, and there's tenths unless the directions say otherwise. All right. Number 7. Now, it's not compound interest, so you're using one of the formulas on the right. Which one will we use? The third formula or the fourth? Yeah, the third. Look, it's the same idea. If you look at number 8, underline the word continuous, because that's your clue that you use in the fourth formula. Whereas 7a and 7b, you use in the third formula, because it's not compound interest, so you're not using one of those, but it's not a continuous rate, so you're not using the fourth one. All right, set it up, and let me write out the formula. It's very similar to what we were just using. Except now you could have a negative rate. In fact, we do here because it's depreciating. And so, be careful. Let me close in. The new amount is the smaller amount. The original amount is 56,000. And then time is what? That's what we're trying to find, actually, isn't it? Okay, and the rate is 15%. So 40,000 is the new amount, 56 original. And it's really a negative 0.15 for the rate because it's depreciating. So be careful about that. Yeah, it's going to be similar, at least to start with. Divide by 56,000. The base is actually 0.85. This one's going to be a little different now. And I've shown you two approaches you can take. I'm going to show you both approaches. You could just write this as a log problem, log base 0.85 of that answer equals the exponent. And frankly, these calculators, they can type this in. It's possible in the newer ones. But if you're not sure how to do that, then just do the way we did before with the change base formula. So rewrite it with log of a new base, which I usually use e, of the original argument over log base e of the old base. Now before we type that in, I'm going to show you the other approach. How to get to the same place. So like I said, one approach, write as a log problem, then use change base formula. Or take log of both sides. So I'm going to do log of the left side equals log of the right side. And once again, as soon as you do log of a power form, you can do what with the exponent? Michael? What can we do with the exponent? I'm sorry, say it louder. Yeah, it becomes a factor. Move it out in front for a factor. That's how I normally talk about it. So once you take log of both sides, move the exponent out in front, and then now it's a separate factor. You can just divide by natural log of 0.85, and you get the exact same thing we got the other way. And then now type it in. And once again, be careful. What was it? Anything, make sure you close parentheses before you divide by the other log. And I got 2.07. That's 2.07 what? Years, yeah. Now, the directions say to round. In other words, it's 2.1 years if you round the nearest tenth, but it said to the nearest whole year. So really 2 years is what I want to hear. And I'm serious, part of your job is to make sure you follow directions. And so if you didn't put 2 years, then you don't get full credit because it didn't say to round the nearest tenth. Okay? Questions about any of those? All right, then just get the rest done. Check your answers as you go.